Hello, this is a quick video to show the progress on the interactions on the Ballast Cleaner instructional program that we've done. This is the menu that will appear when you first boot up the program, and by hitting begin it will show you the different modules that you can choose. The one that we're working on at the moment is the OP1 startup procedure, so by hitting that it will load up the scene and place you inside the cabin. The control system we have for navigating around the cabin is nice and simple. It's just a mouse-based control system. By holding right mouse button and moving the mouse around, the camera will look around, so you can pan around and look around the interior of the cabin. If you release the right mouse button, you get the cursor. The cursor can be used to hover over all the different controls that you can interact with. Switches are controlled by mouse wheel forward or backwards. We'll turn them right or left, and buttons are controlled by just left clicking on them. In the top right corner you have your objectives. That just literally shows you the next button that you need to press to forward the program. This is the training mode at its most basic. This one literally says press this button, flip this switch. Once you've played through the objective once like this, the idea will be that you will then do another one which gives you a much more broad objective. So rather than press the chain drive main switch on, flip this switch, do this button, it'll just be prepare the chain drive or make sure you have enough air pressure, that sort of thing. It'll be a much more broad categories of objectives, and then once you play through those, the final example will be to play through the whole thing without having any prompting at all. And so as you can see, chain drive's main switch to on, so if you flip that on now with mouse wheel up to flip the switch to the right, the objective then changes to set working air button. The little text pop-up here is just a log of all of the switches or buttons that you've pressed so far. That won't be in the final one, that's just for help with bug checking, and so you can actually create a list of all of the controls that the user has pressed, so you can see if they ever do anything wrong. You'll always have a log of every single button that they press. So working air button to on. This starts the indirect brake line getting some pressure. So after 5 seconds we can set the hydraulic system pressure on, which will start building up pressure over here as well for the working air. And while that's building up, we're going to go over here to the touch screen which we've started working on, reset the TBC and initialize a fresh one. Okay, let's set that to manual, and then driving systems 1, 2, I want master 2 and driving cabin 2, and then engage the clutches. Then we can't do anything else until the working pressure gets to 5 bars, so if we watch that. Another thing we've done as well is we've coded the brake pressure. We haven't got any information about the brake pressure feed yet, so at the moment these are just taking a lot of their values off these dials. So that one there is actually showing the value of the indirect brake line at 5.7. Excuse me. Okay, now we've gone past 5 bar on that. We can unlock the trolleys and then lower them, and you can see each switch we do proceeds the objective onto the next one. Distance measuring wheel, unlock and lower that, and unlock the cutter bar, and set the chain drive to manual. Open all the locks. Okay, now we're at the stage where we can move the actual arms themselves. The controls for the arms can be done in multiple different ways. You can either actually have the joysticks that we have set up in the photographs that we've sent before, or you can use them using just a gamepad, or in the way I'm doing it at the moment is just using W, A, S and D to move the left hand control stick, and the cursor keys to move the right control stick. The way we are programming the required position for the arms at the moment is using these two little orbs. You can see one there, the red orb is attached to the placeholder model we have for the arm here, and the blue orb is the target position that it needs to be in to be classified as being in the correct position. And so as we can move this around, you can see the arm moving either outside the window here or on the camera, and if those two orbs touch each other, that tells the program that that arm is now in the correct position. So now it's cycled to moving the right arm. So you can see the red orb for this one here, but the blue one is actually behind this strut, so you can only see the blue one in this camera here. So if we move that in, you can see that's the system we're using for making sure the arms are in the right position. We can make that more or less accurate by increasing the size of those target spheres. We can also make the spheres invisible if we want them to, if we want the user to actually have a more intuitive knowledge of where those arms need to be positioned, rather than having those reference orbs there to guide them. And then once those are in position, we just carries on going to the next startup sequence, which is the ALC button, which is, I believe, in the measuring system. Yeah. So again, these are just another reproduction of the touchscreen interface that's in the real one. So set the ALC, connect the ALC, that switches all the data measuring over to ALC, and then set these to calculate. And then we're just going to carry on matching up all of these interfaces and objectives over to what they were on the induction, on the training video that we were sent through. We're going to keep matching those through. We're going to replace these placeholder models that we've got with the ballast cleaner in that see out the window over there with more detailed and high fidelity models, and then we'd like to have the ballast underneath here actually deform and move and dig trenches as the work is being proceeded. Okay, I hope that gives you an idea of the sort of thing we're working on. And feel free to give us an email if you've got any questions or comments that you'd like to know the answer to. Okay, thank you.